Okay, Bismillahirrahmanirrahim. Today I like to talk about a very important topic, and that is bar graph versus a histogram. They look very similar, and you've probably seen both of them before, although you may or may not have been familiar with the nuances or differences between the two. Both of them will have, like bar graphs like this, okay, like bars, right? But they will be different. There will be differences, okay? So the critical difference between the two is actually what goes on the x-axis over here. It's very important to understand. In a bar graph, okay, what goes on the x-axis over here are categories. Okay, categories. On the other hand, we'll go for a histogram. What goes on the x-axis are not categories, but a range. In other words, there's some kind of scale, like 0 to 100, like test scores, for example. A test score of 65%, whatever. So here you have a range, and here you have categories. And I'll show you, demonstrate the difference in more detail here. And for both of them, on the y-axis, it's frequency of occurrences of either these categories or those scores, etc. So frequency. So the y-axis for them both is frequencies, x-axis where the critical difference between the two is. Okay, to illustrate this further, let's look at this, okay? So here's a mini presentation on bar graphs versus histograms. Now look at this here. Now this is a bar graph, okay? And as you can see, in the bar graph, there are distinct categories, like blue, green, brown, hazel. This is eye color in Mrs. Wood's class. I don't know who Mrs. Wood is, but I found this on the internet, so that was pretty good. So, so this is category. There's no range. It's not like, okay, 0 to 100 or something like that. There's no range here, see? There's no, you don't see any numbers, right? There's no range. So it's distinct categories. And on the y-axis, as you can see, there are a number of students present. So blue eyes, 8 students. Green eyes looks like 3 students. Brown eyes looks like 9 students. And hazel color eyes, there are 4 students. Of course, you can have multiple categories in one bar graph. So this is a bar graph. Now, a histogram is different, see? So this is a bar graph again. Look at this, categories. USA, India, UK, New Zealand, and Japan, okay? And I don't know what this is for, but whatever. So these are categories, and this is some, whatever, some frequency or whatever this bar graph happened to be about. A histogram, on the other hand, is not categories. See, there's a range. From 100, 150, 200, 250, 350. It goes from small to wide. There's a range of numbers. Okay? And again, on the y-axis, here's the frequency. You also notice here that in the bar graph, for every category, there's a bar. And then there's a space in between because these are distinct entities. There's no continuity between the two. So there's usually like spaces between these bars. Whereas in ranges, you don't, whereas in histogram, you do not put gaps between these rectangular histogram thingies, okay? So frequency both on the y-axis, but categories in the first one, and ranges, number ranges in the histograms. Now, this therefore should be immediately recognizable to you as a histogram. So now compare this histogram over to this histogram presented over here. See, over here just some numbers and then some frequency. Now this histogram is slightly different because this is a percent histogram. Okay, so this is, I don't know which weight distribution this is. I just picked this up. So this is weight distribution going from like, looks like 60, 70, I don't know, kilograms, I hope, to all the way up to like extreme obesity here, weight. And instead of having numbers of people with certain different weights, like number of people with certain eye color, it's given percentages. So how many people are like 110 pounds, whatever, it's like 5%. How many people are 150 pounds? It's like, I don't know, it looks like 14%. So on the y-axis, this is a percent So this is called a percent distribution. Now, if you understand that, then you understand that all of these percentages must add up to 100%. So if you add up the number of all of these bars, percentages wise, they will add up to 100%. Okay, so this is a special histogram of percentages. Okay, and this is called a percent histogram. Okay, now compare that percent histogram to this one over here. Okay, this is not a percent histogram, this is because these are just frequencies of certain things. They don't add up to 100% because you're not talking about percent, you're talking about absolute numbers. So there are different types of histograms. This one suggested here is a percent histogram, and that's important for us for the understanding of some of the topics we're going to talk about in this chapter. So again, notice the bar chart over here, different categories, gaps between bars, and these are frequencies. And this is a histogram with a range of numbers and frequencies on this side, and they may or may not have to be percentages. Here's another histogram. Now, this is interesting histogram, and this is not percent histogram, and it's not frequencies. This is probability histogram, which is what we're ultimately interested in talking about in this chapter. So we started this topic about bar graphs and histogram. What we really wanted to end up talking about is actually this, and this is probability histogram. And I don't know what room rental units are talking about over here, but what is it? Okay, if you're trying to look for a room, it's easiest to find a 4-room rental unit. It looks like the probability of finding that is like 33.7%. The probability of finding a 5-room unit is 23.3%, etc. So, and you also understand that all the probabilities will also add up to 1. Okay, so this is a probability histogram. Okay. Now I want to elaborate on this probability histogram. Okay. Now let's say you roll 2 dice. Okay, this is the example that's given in your book. You're rolling 2 dice, and then the question is, what's the probability of rolling a 7? Meaning the sum of the 2 numbers is 7, like over here. What's the probability of rolling a 7? 6 plus 1 being one example of a 7. To do that, you have to understand how many different ways you can roll these 2 dice. So here's the first dice, and here's the second dice. So you can get, and you put all out, you can get 1-1, that will give you a 2. You can get a 2-1, that will give you a 3. You can get a 4-1, that will give, and 3-1, that will give you a 4. And you can get a 4-1, that will give you a 5. You can get a 6-1, you can get a, that's 5-1, you get 6. You get a 6-1, you get a 7. And then with this, you can get 1 and 2, you get 3, 2 and 2 will give you 4, 3 and 2 will give you 5, 4 and 2 will give you 6, 5. So like this. Now, when you do this, all the different possible sums, you'll see that when you roll this, so this is a table of all the possible combination, the sum of the two, of all the dots, okay? When you do this, you'll see all of these are different ways of getting a 7. 6 plus 1, 5 plus 2, 4 plus 3, and 3 plus 4, and 2 plus 5, and 1 plus 1, 2, 3, 4, 5, 6. So 6 out of 36 possibilities. So 6 out of 36, right? So there are 6, and there are ways of getting a 7 as a sum out of 36 possibilities, and that is 1 out of 6. So there's 1 out of 6 chance that you roll a sum. That is 7. How many ways to get a 12, right? As sum? Well, that's only one way to get that. That's 1 out of 36. Okay? And same thing. How many ways of getting a 2? That's actually only one way of getting that. That's 1 out of 36. How about getting a 4? Well, here's 4, see? There are 3 ways of getting a 4, right? Okay, so that's 3 out of 36. That's 1 out of 12. Do you follow? So this is this chart of all the different ways of getting different sums. Now, if you were to plot this out, okay, all the possible sum are, this is the lowest sum you can get is a 2, right? Because 1 and 1 will give you a 2. You can't get, like a 1. How are you going to get a 1? Unless a dot is missing or something like that. So, so the lowest possible score is a 2, the sum. The highest possible sum is a 12, okay? And this shows you the probability of getting all different kinds of sum. The probability of getting a 3 is this. The probability of getting a 4, okay, is this. The probability of getting 5 is this. So the most likely sum that you'll get, in fact, is a 7. So when you roll a dice, the most likely outcome of as a sum would be a 7, okay? So this here is a probability distribution. Probability distribution for sum of the numbers for 2 dice. Okay, so this is a probability distribution. Okay, remember we calculated the 1/6 probability of getting a 7, right? And 1/36 probability of getting a 12 or a 2. Okay, do you also understand that when you add up all of these probabilities, probability of all of these, okay, so the probability of this, probably getting a 2, 3 plus, if you add all of these probability, you'll get 1, right? So that is a probability distribution. So if you draw a histogram of the sum of this dice rolls, probability of getting a 2 is this, as a sum, probably getting a 3 as a sum, probably getting a 4 as a sum, probably getting 5, 6, 7, 8. This, okay, is will look like this. So this is a histogram for the sum of dice roll, okay, and this is a probability histogram. It's not a frequency, absolute frequency histogram. It's not a bar graph. It is a probability histogram for the sum of dice. And this is a very beautiful example because it shows you some very unique features. This histogram, as you can see, is it's like a bell shape, right? That's one thing that we observe. In other words, half of it over here and half of it's over there. So this, if you apply this to large numbers, this is called a normal distribution. A normal distribution is kind of like one hump, kind of like symmetrical histogram. Okay, so we're going to discard those here for now. So what we have learned now is the following. Okay, so I shall summarize and finish. Okay, inshallah. So we learned the difference between a bar graph and a histogram. A bar graph has different categories on this side and frequency on this side, and the bar are separated from each other like this. Okay, and a histogram has a range on the x-axis and frequencies on the y-axis, and the bars are connected to each other like that. And among the histograms, we talked about different types of histograms, including just plain frequency histograms, right? And we talked about percentage histograms, okay? And then we talked about, very importantly, a probability histogram. Now, probability histogram was of particular interest to us for the remainder of this chapter. And on this side, we have probability of a particular event. And here we have the particular event. And this is listed as a range again. And that's why it is a histogram. And we got something like this. And that was our probability histogram. Inshallah, next time we will elaborate on these topics. And I hope that you appreciate some of these important things, and take time, if you have not, to review this, if you don't mind. Until then, until next time, as-salatu was-salamu ala rasulillah wa rahmatullahi wa barakatuh. Assalamu alaikum.